Now we are going to dive into part 3 of lecture 4. After finishing data preparation and data collections sections, we are going to dive inside evolution of big data. So we already, for evolution of data handling practice, we finish data fundamentals within part 1 of the lecture 4, and part 2 we go inside evolution of data collection and preparation. At this time we are going to touch very important part of our lecture, evolution of big data. Not only this is important for lecture 4, but also for a whole classes, which is AI and big data. We will touch theoretically this part, and later on we will go more technical part of big data processing, and later on we will do some practice. We will use some tools, and we will do some hands-on practice. This is very good news, and I'm sure that you will enjoy. Okay, let's start with the core question. What is the big data, right? For this evolution of big data. And this is very important part of our lecture. Rise of the big data. It is characterized by many V's. So here you can see some V's, but like volume, velocity, variety, veracity, value, we will talk more. Big data is very important. Today's system generate massive amount of data at unprocessed. This is very important. Many solutions created high speed data, diversity of data type, structure, semi-structures, and unstructures require advanced processing technique. Why it is essential to understand evolution of big data? Please pause. The answer: understanding how big data has evolved helps us appreciate tools and techniques we use today. As data grows exponentially, mastering big data is crucial for AI and machine learning application. So companies like Google process terabytes of data daily, Google, to refine their search algorithm and making it possible to deliver accurate results in milliseconds. So the evolution of big data in this lecture, including key area of discussion for today, we will touch to what's the big data. Large scale data set with a high volume, velocity, variety. Then we will go to history of big data, from early data collection practice to modern day AI-driven data analyzing. Then we will key trends, the rapid growth of data generation from social media to IoT devices, evolution of big data models, from relational database to NoSQL and distributed computing frameworks like Hadoop, big data ecosystem, a complex system including data collection, store, and analysis tools. Why learn big data, right? It is crucial for modern decision-making, innovation, and competitiveness. Data storage insight. Exploring data lakes, data warehouse, and cloud storage solution. Source of data generations. Many sensors like IoT devices, social medias, business transactions, and more. Industry application like finance, healthcare, retail, and more industries are transforming through big data. Increased use of AI and machine learning is the future of AI to extract deeper insight. So let's go for the what is big data. Let's start with the definitions. By definition, big data, please attention. Big data is characterized by its volume, velocity, variety, and many V's. It includes both structured and unstructured data that require advanced tools and techniques for analysis, such as machine learning and AI plus big data processing like Hadoop, Spark, we will discuss. Historical perspective. The term big data was first in 1979. It is used, and by early 2000s, it gained prominent alongside the rise of Web 2, which I mentioned. So websites started generating large-scale data from user interactions, searches, and social media activity. This required new method to store, process, and analyze data. Why it is important? It is revolutionized industry by enabling data-driven, as I told you, why data, decision-making. Organize can analyze vast data set to find pattern and make decision. Whether it is healthcare using AI to detect the disease early, or finance firms improving fraud detections. Big data is driving force behind these breakthroughs. So why big data important and essential? Because big data serve fundamental of innovation in industries such as AI and IoT, finance, and healthcare. By analyzing enormous data set, organization can migrate risk, identify new opportunity, and make more informed decision. In a sense, big data not only enhance current decision-making process, but also pave the way of future innovation and transformation. So, for instance, in healthcare, analyzing large datasets from the patient records can reveal pattern that leads to early diagnosis of the disease. In retail, companies use the big data to personalize customer recommendation based on past behavior, leading to higher sale. So, history of big data. In this slide, we trace early foundation of big data, which is a start, pre-19th, when the relational database and personal computer began increasing volume of data we generated. In in the 19th, World Wide Web become publicity available, and terms big data was first used by NASA scientists. So in 1997, remember, maybe this is the question of exam. By the early 2000s, big data truly took off with the rise of big data and introduction of concepts like 3Vs. Start from 3Vs 2001. The decade also saw creation of key technology like Hadoop, launch Amazon Web Service AWS in 2006. In the late 2000s, big data became mainstream with the global governments and organizations using it to manage large-scale data projects such as, like India's biometric database, Aadhaar. It was the name. So let's continue big data history in the another slide. So in 2010's big data explosion, Eric Schmidt famously stated that every 2 days we create as much as information as all human civilization did up until 2003. This statement perfectly captured the growth rate of the data generation during this period. By 2011, McKinsey identified big data as a key factor for innovation and competitiveness advantages. This is probably make the organization worldwide to invest more heavily in the data analyzing. In 2012, that Obama administration in the US announced that $200 million investment in a big data research, signaling the government recognition of its importance. By 2013, digital universe has grown to the estimation of 4.4 zettabytes of data, emphasizing just how vast realm of data had become. And 2015, big data wasn't just about the volume. New dimensions were added, like veracity and the value, 2V added, highlighting the complexity of the managing such a massive data set. So convergence of AI and big data in 2010, the truly transformed industry. So in 2010, AI and big data, which is topic of this class, is merged together. And in 2016, AlphaGo, an AI system, developed a DeepMind. AlphaGo developed DeepMind and defeated world champion in Go, demonstrating immense power of the AI and big data. AlphaGo was very famous. If you search, you can get many information. 2018, GDPR was introduced in EU, highlighting increasing global concern over data privacy. and usage. And 2019, the global big data market reached 1.189 billion, further solidify its impact on the global economies. So in the 2020, COVID-19 pandemic accelerated digital transformation, forcing business to rely on more data-driven decision-making than ever before. So by 2021, it was estimated that around 79 zettabytes of the data were being created, captured, and consumed globally. And this is many data overloaded. 2022 onwards, technology like edge computing, 5G, real-time big data processing. So this was there has been a growing emphasis on ethical AI. So ethical AI and responsible data usage. Big data is also playing a key role in addressing, global challenges such as climate change. So this was, I made within 2 slides. I spent too much time prepare this very compact history of big data. Now let's go for key trends and observation of big data. So the exponential growth, one of the key trends of the big data. Data volume has skyrocketed from a gigabyte to zettabyte in such a few decades, reflecting how much data was generated daily. Another is a technological enabler. Advancement in data storage, the processing power, and faster network speed have made handling large datasets more efficient and accessible. Shift in data type. Initially, structured data, dominated. Now we handle a diverse mix of structured, semi-structured, and unstructured data, such as social media posts, videos, and IoT data. Another important trend is the democratization of data. That means cloud servers have allowed business of all sizes to access and merge big data, not just large corporations. However, ethical and privacy concerns have come to forefront. As more data collected, the growing awareness and new regulation around the data privacy and ethical usage. And big data convergence with the AI and machine learning is also noteworthy and very significant. It is become fuel for AI, powering advanced analytics and making machines smarter in their directions. And finally, the industry-wide impact, undeniable, really. Big data has transferred from, niche technology concern to the critical element driving decision-making in the healthcare, like finance, retail, like manufacturing. So let's go with the evolution of some big data model and characteristic. I want to know how many, because when we talk big data, sometimes somebody said 3V, somebody said 5V, somebody said 9V. I want to know. So let's see. I made, many resources talk, many book different information, but I made very nice slide which easily you can get very good information about that one. First one is the 3V model. It starts from 2001. And then 4V, 5V, 6V, then 9V. So we began with the 3V model by Douglas Lancey, introduced in 2001. The 3Vs include the volume, the sheer amount of data, velocity, the speed at which data is generated and processed. Variety means different sort of type of data, such as text, image, video. Then for 4V, IBM later expanded this model with 4V, means add one more V. This added veracity, which emphasizing for ensuring the accuracy and trustworthiness of data. So because of that, add one more V. Next, 5V model by Yuri Demchenko. This model introduce and add one more V. This model introduce value, stressing the importance of extracting that actionable insight. Remember, at the end is the actionable, action, able to action, insight from data. And later on in the 6V, Microsoft introduced 6V model. It adds visibility. That visibility focusing on the making data easier to visualize and interpret for data makers. And finally, the extended 9V, actually 9V considered as a extended model, broadens the scope of even further. It includes aspects like validity, volatility, and valence. We will talk about that one. Vagueness and viability. Addressing challenges such as data quality, retention period, long-term sustainability of big data initiative. As you can see here, that validity is ensuring data, whether it's correct or not. Volatility, considering data's shelf life and retention period. So the others we will discuss in coming slide. So let's see figures. This would be very helpful to you. You will understand many things through this slide. So mainly start from Douglas Lancy, the first big data 3V model, volume, variety, velocity, and then IBM 4V, which is, as you can see, compared to here, add one more velocity. This is 4V. And as this figure easily mentioned, that you need to add one V more as a value, and adding more V's coming to 6V and then 9V. We will talk about that one. As you see in this figure also, when we talk about the volume, that is regarding the how much records archive, tables, and transaction. When we talk about the string data, means velocity, process, something like that. Variety means many sort of type of data, structure, semi-data, and structure. And veracity, trustworthiness or authenticity or origin, consider, and especially in the value is a hypothetical correlations and events and statistical. So let's quickly dive inside each one within other slide. Here the 3V model provide a framework to understand big data through the three main characteristics. Volume refers to a sheer amount of the data generated today. Let me give you an example, like think like Meta company or Twitter, which generate terabytes of daily data. So velocity is about the speed at which data flows. If I give you an example, like New York Stock Exchange generate 1 terabyte of trade data every day, while IoT devices continuously generate a stream of data. So there is challenges which through the velocity, real-time data processing. So challenges here is the real-time data processing demand low latency infrastructure like Apache Kafka. So challenges here in the volume is handling this amount of data require advanced storage solution like Hadoop or AWS. And variety highlights the different types of data. Like example, structured data such as SQL database, unstructured data such as social media posts, and XML data such as semi-structured data. So challenges here, integrating and analyzing such a diverse data required special tools, right? So this is the very challenging part of data. Another form model which we can talk about that one. In the form model, we build upon this form model, build upon three 3V framework by adding a crucial fourth element, veracity. So veracity refers to trustworthiness and accuracy of data. What is the definition? Ensuring data is reliable, free from uncertainty, free from inconsistency, simply free from any bias. So why it is important? As businesses make critical decisions based on data, ensuring its quality is, significant. Challenges, around 1/3 of business leaders report concern about the accuracy of data they rely on, making data quality assurance a significant, challenge. With the 4V model, veracity ensures that massive volume of data generated can be trusted for informed decision making. So this is a very critical, important point. And so if I give you example for like 5V, consider a hospital generate massive amount of data daily, including patient record. Imagine data and real-time data from medical devices. This is the volume, because this is 4V, right? Volume. Velocity, this data is often streamed in real time, especially from monitoring equipment like heart rate monitors, which needs to be processed quickly for real-time decision. This is velocity. Variety, healthcare data come various forms. Structured data like electronics health record, semi-structured data like emails, forms, unstructured data like medical image, doctor notes. And the last one, veracity, ensuring that data is accurate and reliable is crucial. In healthcare, inaccurate data can lead to wrong diagnosis and treatment plan. For instance, if medical devices stream incorrect data, it could be mislead doctor in making final crucial decision. Therefore, healthcare provide should be quality very good. So in the 5V, in addition to 4V model, another critical layers, Yuri Demchenko introduced 5V, which is value. It is not just about managing or storing vast amount of data, but rather about the extracting true and actionable insight that can drive meaningful business decision. So if I return back to the previous, why value important, before I give the one example, you can pause. Yes, value is essential because it provides a competitiveness edge. Companies today aren't just collecting data for sake of it. They are seeking insight that enhance their product, improve customer experiences, and ultimately stay ahead of the competition. So when, if I explanation some value of the value, when we talk about the value in data, we mean more just number. It is about transferring raw data into insight that can lead to a smarter strategy and innovation. So think of value as a bridge between data collection and the real-time impact. So value from physical world to digital world, when we have a data, we come back to the real world. This is the value. We check with the reality. Let me complete that example which I started to explain about the medical in the 4V I talk plus one more V value. In the previous example on the healthcare data management within the fifth model value, for that example, the real goal is extract actionable insight from vast amount of the healthcare. Data isn't just stored. It must be analyzed to drive meaningful insights, such as what? Such as predicting patient, deterioration and optimizing resource allocation in hospital. For example, by analyzing data trend, hospital can prioritize critical patient in emergency situations, sometimes some patient in an emergency situation, or forecast future healthcare need. In the world where data is everywhere, those who matters of art of extracting using its value are the ones who lead innovation. Companies that harness data value effectiveness will always be a step ahead. So this is the importance. So let's go for 6V. 6V model expand the previous model by adding crucial element, visibility. So what is the visibility? So visibility refers to how easily data can be visualized and under control and control of the vision. We understood that very well. This is where dashboards, graph, and interactive charts come into play. These tools make it simpler for decision making to extract meaningful insight from the complex data. So why this is important? Clear data presentation is vital. Without visibility, even the best data can be overlooked or misunderstood. By making data easily accessible or visual, business can make informed data-driven decision more efficiently. So there is some challenges, however, right? What is that challenges? Making complex data intuitive and user-friendly can be challenging. It requires careful design to ensure the critical information isn't lost in translation. So if I explain about that same example which talk about the many V for 5V about the medical healthcare in previous example on the healthcare data management, within 6V model, visibility means in that example, visibility the sixth model emphasizes visibility, ensuring that healthcare data is easily visualized and accessible to the decision maker. For better understanding, give you one example, like dashboards, graph, interactive visualization are used by hospital administrative and doctors to what? To monitor patient data and hospital metrics. This allows for quicker, more informed decision. For example, using dashboard to visualize ICU, the decision when if they see well, decide very well. The resources availability enable hospital administrator to manage critical care unit more efficiently. In short, the visibility of data can make or break decision-making process. That's why this fixed V is so crucial in the data-driven world. Remember, data-driven world. What is the next? After 6, now we don't have a 7V. Come to, 9V. So we directly deal with the 9V. So in a 9V, as you can see, validity, it ensures data is accurate and fit to its purpose. In field like finance, ensuring validity is validate. It is vital to, as an incorrect data can lead a major error. The other one is the volatility, means this address how long data should be kept. Volatility. For instance, in trading platform, real-time data is volatile and may only be relevant for a short period. Yes. When the corona finish, you talk about the corona is useless. And the third one, vagueness, which is especially important when dealing with the ambiguous data, like interpreting social media posts where sarcasm or context may change meaning. So these three means validity, volatility, and vagueness are crucial for improving how we handle the extract. In previous example on the healthcare data management, let's continue for validity. That example in the healthcare data validity is crucial, ensuring that data is not only accurate but also appropriate for intended use. For example, if medical research data is incorrectly categorized or outlaid, it may lead to incorrect conclusion and treatment protocol, which is very dangerous. Volatility for healthcare data often has a limited shelf life or retention period. For example, patient data may need to be achieving certain goal, and it can be archived or deleted after a specific time to comply with the privacy regulation. Hospital must manage retention and deletion of data properly to ensure compliance and relevance. So this is very important. Vagueness for medical example, addressing ambiguity in the healthcare data is essential. For example, free-form doctor's notes can contain vague language and shorthand that may be difficult to interpret. Any automated system hospital must be use NLP, natural language, other tools to ensure that even vague and ambiguous data is processed well. So there is one more extended 9V included all aspects of 9 model plus this, but still it is called 9V. They don't call 11V, remember. So that is focusing about the valence, refer to the interconnectedness of data in social and networks analysis, for example, relationship between individual provider, deeper insight. Why? To manage this interconnection at the scale is a major. And finally, visibility, focus on the ensuring that big data viability, focusing to that not only work technically but also are economically sustainable. It is about making sure that projects generate long-term value, balancing cost with the benefit, viability, really under our capability that for long term we support money, like assessing the ROI of big data initiatives. So if I give you an example of medical healthcare for valence, healthcare system offer needs to analyze how efficient piece of data are interconnected. For example, understanding how a patient heart rate data correlated with their medication and lifestyle habit can provide deeper insight. This interconnection valence enable doctor to make more informed decision by understanding relation within data, leading better innovation. Viability, long-term sustainability of the healthcare. Hospital must assess whether the data collection is still many things, be effectiveness for a long time. Hospital may need to be adapt more scalable cloud-based solution to ensure they can manage growing amount of patient data without sacrificing efficiency and security. So this is importance of the extended VS holistic approach, quality assurance, strategy alignment, complexity management, lifestyle. We don't have much time. You can read, stop and read this one. This is why extended V, we are going to from 9th to extended V. So implementing like usually it is used for assessment stage. The reason I put more because this is more usable. Planning phase, implementation phase, monitoring, optimization, monitor observation. Once your system is update and running, continuous monitoring is essential. Keep an eye how well each V is addressed using metrics like data freshness of the volatility and decision impact for verdict and interactive improvement. This is finally remember that big data project involve over time. Regularly you need to control, adjust your strategy to handle new challenges and shifting priorities in your big data initiative. So now let's talk about the big data ecosystem. When we talk about the big data, first we have data collection, right? Where data is generated for ecosystem. So data generated and like sensors, media. Then data storage. We need to take over of the data like Hadoop and cloud system. Once the stored data is proceed more processing tool like Spark and Flink. And the analyzing, the machine learning and data mining techniques to analyze data. So supporting technology for ecosystem is the cloud technology and the network, ensuring data connectivity and visualization, graph, dashboard, something like that. So why learn big data? Why we should invest our time in learning big data? Pause video. Answer is the simple answer. Big data is relevant to almost every industry, whether it is healthcare, finance, retail. There is a high demand for professional skill in the managing analysis. So because of that, on top of that, companies leverage big data again. Competitive edge using the data-driven strategy to optimize the process, make better decisions, and ultimately outperform the competitors. This is why we need data such a data storage insight. This give you very nice insight. Concept of data storage. When we talk about the byte, smallest unit of data, a byte, think one byte as a single grain of rice. And the megabyte, it is like 8 bag of rice, megabyte. When we say 8 bag of rice, it is still relevantly small. In the grand scheme of thing, but it is hold moderate amount of information, like a simple document or short song. This is megabyte. When we talk about the gigabyte, consider three semi-truck filled with rice. This is where data begins to see a scale grow as a gigabyte. And think of entire movies is a gigabyte. One movie. High resolution photo album is a gigabyte. Petabyte, consider petabyte of rice could cover entire city of So zettabyte is a field Pacific oil rice and astronomical in size like 1 octillion byte. This is the size of that one. So source of data generation like people, device, social media, internet thing, global usage, industrial application, retail, e-commerce, healthcare, life science, finance, banking, manufacture, IoT, logistic. Case studies like Google PageRank algorithm developed by Larry Page, Sergey Brin in 1996. You can pause to see how it works because since we don't have time. Another is the Netflix recommendation system component mentioned here, big data challenge and result. This is very important, critical. And real-time traffic management or finance fraud detection. And future trend is emerging technology like edge computing, 5G network, quantum computing, advanced analytics like AI and deep learning real time. This is using the future trends in the big data. Data governance, increasing the focus on the data privacy security. The others, like many regularity, compliance. This is the future trends of big data. Let's quickly recap lecture 3. In the lecture 3, we went go DIKW pyramid evolution, talk about the traditional pyramid data information. Then we add optimization, program enrich model, add optimization and add the program to it. And then we talk about the data fundamentals. And in the that was in for lecture 2 and lecture 3. And in the lecture 4, what we did, it is historical progress of the evolution of data handling. You can see what we discussed here about the manual data, electronic data, relational data, personal data, and then becoming the advantages from punch card to cloud storage and improved data quality. This evolution, including integration of AI data and machine learning. Key point covered here, like characteristics of 3V to 9V, big data ecosystem, industry application, case study, and future trends. And keyword cover in the last moment about the data role has evolved. So here in the last recap that we try to simply explain that here you can read later, but shortly in this line, data evolution covered, focus on the quality and ethics, and then technological progress and AI integration, and then future challenges, and finally importance of staying updated. This is the key takeaways of the future outlook. So finally, what we did until here for evolution of AI and big data, we mentioned section 1, foundation of data and knowledge, and then evolution of data handling. Section 2, we finish it. Section 3 remain evolution of intelligent decision making, which is include evolution of AI and data-driven decision. So please prepare yourself, watch the video many times, and thank you for attending today's lecture.